Here we go. Chapter 5 we just finished. Chapter 5 we just finished with quadratic functions. Does anybody remember what made a function quadratic? Jess?
It has like an x squared, right?
Excellent. Nice job, Jess. Yes, if it has an x squared, it was a quadratic. Well, chapter 6 we start looking at higher level functions, functions with an x cubed or an x to the 4th. And seeing what can you do with those functions, what do their graphs look like, how can you solve and simplify. But before we do that, you have to know the different names of the functions. So if I introduce a cubic to you, you'll know what a cubic means. So we're going to review a few basic terms. Look, how do you name a function, and then work with some of the simplifying with it. So first of all, a monomial. That's one of the most basic terms we look at. A monomial is a single term. A single term. And that single term could include, so a single term which could include a variable, comma, a real number, or a product of the variable and real number. So it's one single term. And then after each definition, I'm going to give you an example just so you can see what that's describing. Example, a monomial might be something like 5x cubed. It could also be just the real number 5. What makes it a monomial? There's only one term there. Okay, a polynomial then is either a monomial or a sum of monomials. So let's go ahead and let's write that in. It is a monomial or sum, S-U-M, of monomials. So example, something of a polynomial would be 5x cubed plus 5. That's a type of polynomial. We'll look at that. That's actually a binomial. Or, again, it could just be 5x cubed. 5x cubed is a polynomial. It's the special type of polynomial called the monomial. Next term that we look at, I'm going to be using this word a lot, so make sure you know what this word references. Degree. Degree is the highest exponent in a polynomial. So let's write that, and then we'll take a look at an example. It's the highest exponent in a polynomial. And then let's take a look at an example. So example, if I have something like 5x to the 6th plus 3x to the 4th, what would be the degree? What would be the degree? It would be the 6. The highest exponent that you see would be the 6. So go ahead and circle that 6 and say this polynomial would have a degree of 6. And then lastly, I referenced this in your bell ringer. How do you know if you have a polynomial in standard form? Standard form has all like terms combined, and the terms are written in descending order of power. So here's an example of something in standard form. We have 2x cubed minus 5x squared minus 2x plus 5. Notice there's no terms we could combine. They're already, any like terms have already been combined, and the highest exponent is first, and then the other exponents are in descending order. Now I have a question for you. If I look at the number 5, this is a constant, what would be the exponent, or what would be the degree of the 5? This one's a little tricky. David? The degree of the 5, you're right, is 1. If I looked at the degree of the variable next to the 5, so let's look what 5 is equivalent to. 5 is actually equal to 5x to the 0 power. Now David's not wrong in saying 1, and here's why he's not wrong. Does anybody know what a number to the 0 power is equivalent to?
1.
It's actually equivalent to 1. Let me show you on your calculator. If I take a look at, where are my calculators? They're kind of all over the place. Here we go. If I did 5 raised to the 0 power, the answer would be 1. So any number raised to the 0 power is equal to 1. So if I have 5 raised to the first power, that answer is 5. But if I take a number like x, and x could represent anything, x raised to the 0 power is equal to 1. So if you're actually asking what is the degree of 5, or you're looking at what is the degree of the variable next to 5, that degree would actually be equal to 0. Because 5 is equivalent to 5 times 1. So in referencing degree, you're looking at the degree of the variable. Mariah?
So is the degree 1 or is 5
The-
equal 1?
The degree would equal 0 on this term, and the number is 5. Jess?
So then is the degree for the negative 2x 1?
The degree for the negative 2 would be 1. Yes, the negative 2x would be 1.
Okay, because I thought that was a 0, so I was really confused.
Oh, that's supposed to say 1. There's just, I circled to show that it went 3, 2, 1, and then this would be an x to the 0. That's how you can see that those exponents are in descending power. 3, 2, 1, 0. Excellent. Any questions on that? Okay, that's going to help us in classifying different polynomials. Polynomials have different names depending on what they are. But the beauty of this is just like you have a first name and a last name, like Bond is Bond Bailey, first name, although that's actually your middle name, right? But it's a good name. So we have Bond and then Bailey. We recognize him by a first name and a last name. In the same way, any polynomial, you're going to name it by a first name and a last name. The first name is what degree we have. So if you have a degree of 0, that's just like that number 5 over here, you would call that a constant. If that constant is just by itself, meaning you only have one term, its last name would be a monomial. So an example of a constant monomial would be just the number 5. The degree would be 0 because there's no x there, and then there's only one term. Okay, next one. If your degree is 1, your first name would be a linear. If there were 2 terms, then the last name would be a binomial. So here's an example of a linear binomial. If you have something like 5x plus 3, notice that the power on the x is 1, and you have 2 terms there, so that would be recognized as a linear binomial. If you have a degree of 2, you should all know this. What type of functions have a degree of 2? Quadratic. Excellent. So your first name would be quadratic. And then if you have 3 terms, which we see often with quadratics, then your last name would be a trinomial. So an example of a quadratic trinomial would look like this. 5x squared plus 4x plus 3. The highest exponent you see is 2, and then there's 3 terms. Okay, does anybody know the first name if something has a power of 3 or a degree of 3? Jess?
Cubic.
Nice. Cubic. And the last thing you have to know is if a polynomial has more than 3 terms, then we just say it's a polynomial of how many terms it has. So if it has 4 or more terms, our last name we just call a polynomial of however many terms it has. So example, I'll put 4 in quotations, meaning if it had 4, you would say 4. If it had 5, you'd have 5, and you could keep going. Here's an example of a polynomial of 4 terms. Here's an example of a cubic polynomial of 4 terms. Something like 5x cubed plus 4x squared plus 3x plus 1. Okay, and lastly, you can have different combinations with the last name. But there's 2 more first names we have. This is my favorite one. I don't know why. I just like the sound of it. If you have something to the 4th power, it's called a quartic. So a quartic. Q-U-A-R-T-I-C. It just sounds fun to say, quartic. So let's do an example. Let's do a quartic, and then let's choose a number 1 through 4. Let's say 2. Let's look at an example of what a quartic binomial would look like. If you have something like 5x to the 4th plus 3, this would be recognized as a quartic. What would be its last name? Binomial. Excellent. And the last one's kind of fun too. It's called a quintic. Q-U-I-N-T-I-C. And then let's choose 3 terms. So a quintic, and let's say we have 3 terms. Here's what this would look like. Something like 2x to the 5th plus 4x plus 3. This would be recognized as a quintic. And then what would the last name be? Trinomial. All right, any questions on how to label a polynomial? Lizzie?
This is just a random question.
Yeah.
So usually when you have like a quad something, it's 4. Why in this case is it 2?
A quadratic?
Yeah.
I
If you
don't.
have like a quadrilateral and 4.
You're right. I don't know the answer to that question. I'd have to look into it. Yeah, I'm not sure why we don't just call it like a squared binomial.
Yeah.
That makes more sense to me. We just call it quadratic. I don't know. People much smarter who worked with this and developed it, labeled it that way. I'm sure they have some reason for it. But I'll look into that. I'll see. Okay, real quick here. Every monomial or polynomial should have 2 words, 2 names, just like you have a first name and a last name. One that describes the degree, and the other to describe the number of terms. Okay, so let's practice with this. Go ahead and flip it over. Write each polynomial in standard form, and then classify it by degree and the number of terms. So letter A. First of all, we have to combine like terms, and we have to write the highest exponent first. So which one's the highest exponent that you see there? 2 or 3? 3. Good. So let's combine those first. 3x cubed plus 2x cubed. What does that come out to be? 5x cubed. Good. Which one would come second? X squared. And what would be the last one? Minus 4x. Excellent. That would be the polynomial in standard form. Now name the polynomial. Classify it. What would be its first name? Cubic. Excellent, because we have a power of 3. And what would be the last name? Trinomial. Good. You guys got it. Try the next one on your own. You can use the chart on the previous page if you're unsure. Someone raise their hand, tell me what they got here. Josh.
Linear binomial.
Nice, Josh. Linear, because the highest power that he saw was 1. A linear binomial. Excellent. Why don't you try letter C with your partner? Okay, bring it back up here. Check to see, did you have the function in standard form? And then did you label it correctly? It should have been a quartic trinomial. I love that word, quartic. Quartic, quartic. All right, letter D. Letter D, what do we have to do here before we can put this in standard form? Simplify. Are we going to multiply these or are we going to subtract them? Subtract them. So what am I going to do with this -1? Distribute. Beautiful. So distribute that in. Do I need to do anything? Can I take away the first set of parentheses?
Yeah.
Yes, because you can think of it as a 1 there. And if I distribute a 1, I get the same thing back. -a² minus 3 minus 3a plus a² plus 5. Okay, now I have to combine like terms. Which am I going to combine first? a². Good. -a² and a². What happens with that? Cancels to 0. What do I do next? -3a. And then lastly, what's -3 plus 5? Plus 2. Okay, can someone raise their hand and name this for me? Isabella. Excellent. This is a linear binomial. And then letter E is one like you did on the bell ringer. So remember, you have to multiply each of these once. So I can multiply the x by the 2x to get a 2x². But I still have this 4x plus 1 that has not yet been multiplied. So to multiply, I just distribute in that 2x². What's 2x² times 4x? Good, 8x³ plus 2x². And try to name this one on your own. Name this one on your own. Okay, go ahead and take a look there. Should be a cubic binomial. Cubic binomial. Are there any questions about different types of polynomials and how to classify them? Ruben.
I have just a question for the letter E.
Yes.
Can we divide by 2 or we cannot?
I'm sorry, say that
Can
again.
we divide by 2?
If you were asked to factor,
Okay.
then you could take out a 2x². But if you're asked to leave something in standard form, you want to leave it with everything combined.
Okay.
Good question. But wait, we're not done. Go ahead and flip it over. We are starting the first question on the next one because it still works with classifying by degree and number of terms, which is what you just learned. So we're going to try letter A together. Letter A. Remember, if you're multiplying 3 sets of parentheses by each other, you need to multiply everything together once. So I'm going to show you a method that kind of eliminates errors, because when you're multiplying this many amount of x's and numbers, a lot of errors can arise. So here's the method that was actually shown to me that eliminates most errors. First thing you're going to do is FOIL the first 2. So let's FOIL these first 2 terms together. First times first would give me x². Outer times outer would give me 2x. Inner times inner would give me 1x. And last times last would give me 2. But I have not yet multiplied the x plus 3, so I'm going to keep it in parentheses. And then can I simplify this first part? Yep, it becomes x² plus 3x plus 2 times the quantity x plus 3. Now, I have to multiply this x plus 3. I have to multiply both terms into everything in front in order to simplify correctly. So here's the method that I use that reduces errors. If you separate the x and the 3, so go ahead and write x and then the plus 3, and then copy the polynomial that's in front, so copy the x² plus 3x plus 2 twice, This allows you to distribute everything in and see everything clearly. The other way you can do it is you can just distribute the x to everything in front, distribute the 3 to everything in front, and then combine like terms. But I've just found more people make errors in that way. So let's go ahead and let's continue with this, and then you can choose which method you want. So now I'm going to distribute the x into everything in front. X times x squared, what would that become? X cubed. X times 3x would give me 3x squared. X times the 2 would give me 2x. And then I have to distribute the 3 into everything. So that would give me a 3x squared plus 9x plus 6. And now if I'm putting this into standard form, which variable has to come first? X cubed, good. Then the squareds I need to combine, 3x squared and 3x squared. What does that come out to be? 6x squared. The 2x and the 9x, what does that come out to be? 11x. And then finally the constant at the end becomes the plus 6. Now, after we have that in standard form, the directions say then classify by the polynomial, or classify the polynomial by degree and number of terms. One thing to be aware of, sometimes in your homework they will just say classify by the degree, or sometimes just by the number of terms. It's recognizing that you understand what the first name represents and what the last name represents. But if we're doing it by both here, Vaughn, put it away. Can someone raise their hand and tell me what would we classify this of? Mariah.
Cubic polynomial of 4 terms.
Nice. Cubic polynomial of 4 terms. Excellent. All right, guys, your homework